the magnitude of the sampling errors will be much bigger. And that's basically because the larger the sample size, the more representative. The smaller the sample size, the less representative. So that's the second behavior of sampling errors. I hope I'm making sense, eh? The other one is that if in the original scores the standard deviation was big, let me draw again those graphs which I drew earlier. If you have taken scores of mathematics in this University of Lilongwe students and you plot them, you could have a graph which looks like that. Let's make it more normal. Which looks like that. It's possible. You would also have a graph which looks like, no, we want a normal distribution. That's also possible. What you're seeing here, or you would even have one which looks like that. Still normal distributions, right? This side is same as this. This side same as that. This side same as this. But in here, in this distribution, the scores are falling very close to one another. And therefore, you have a smaller standard deviation. Here, they are slightly spread. So the standard deviation is larger. Here, they are very spread. So the standard deviation is large. Now, if you have a situation like this in the original scores, the raw scores, then your sampling errors will be larger because most of the scores are falling away from the mean. There's more dispersion. If you have this situation, the sampling errors will be small because they're falling very close to the mean. So, another rule of sampling errors is that the sampling errors are a direct function of the standard deviation of the population. Okay? And the last one is this, that when you come up with the sampling errors and you plot them in a frequency distribution, they will be in a normal distribution always, or near normal distribution. And because of that, using the principle of standard scores, you can now estimate from one sample how far away that sample is falling from the population mean. Okay? You remember that formula we're using, which I gave you in the assignments. I gave you one of the questions I gave you, assume that Pearson is in a class of 100 students and they wrote a mathematics exam, and in this mathematics exam, Pearson got 88 and the mean was 77 and the standard deviation was 10. Compute the position. You remember that? In your second assignment, using the same principle which is hidden in that, you can now make inferences. Because now you're inferring when you come up with the sample mean, since we know those sampling errors are distributed normally, then you can use the principle of standard scores to estimate how far away the sampling error is falling from the mean of the population. And that will tell you whether your sample mean is representing the population mean or not. That's the whole principle of inferential statistics. Mafuso. Mulibe mafuso ndio pasa nifuso wange. Basi mweruka tunga tumufuso. Ndiye fuso wanga ndinoti Ashum John in educational statistics we have 500 students in that class, and we gave a test, and John in this test got 88. Oh, 88%. We computed a mean in this test, and the mean is 84%. And we also computed a standard deviation in this test, and the standard deviation is 4. What percentage of students in this class obtained the scores less than John's score? Simuna ndifuse mafuso then langa limenelo kaphela choka mumuzwa kaphela choka izi. An idea sitakati kupanga zimene zikambiri mbiri eti. Give me an approximate answer, because I can see all of you don't have one clue to give me the exact answer. Eh? 125 students got scores less than John? No. Eh? Mwaikumbukira formula ya z-score ija? Tinati score minus mean divided by the standard deviation and A. So what is also known as the net? Hello, how are you? Fine. About essay. Oh, okay. Yeah. You are the one who I said I sent your request to the registrar. Right? I have not yet got a response from the registrar. But what I would suggest is, can you send me a suggested topic? Send me an email indicating the area of study you are in, and you should come up with a proposed topic from that. So, a proposed topic on the essay. So, after looking at the proposed topic, I will give you a go ahead, or I will suggest a change. Yeah. So, if you can send those as soon as possible. Okay. muri bwino saa hayi tiri bwino kaya kumene kuli bwanji 103.
107.
You are missing it somewhere. And I know where you are missing it. How did you come up with the 103 or 107? Yes. So you had the 88 minus 84 divided by 4. 88 minus 84 minus 4 divided by 4 equals 1. Yeah, 1. Now, how did you move from that 1 to come up to 100? Yeah. I think I can remove this head so that you don't have to bother us. You know that 84 is this one, right? And the one you got is 1 standard deviation above the 84, which is 88. So what proportion are you getting here? 34%. So you should have multiplied 500 by 34 over 100. It will give you this one. Yeah? And I was saying there's one tool which you are missing because that you could just read from the standard tables I gave you. You remember those tables? Yeah, it would have given you the proportions. 170? Okay. Now you know that from here to 84, we have half of this population of 500, which means this is 250, plus this. All these are below 88. So that 100, you said we got 100 what? 170. 170 plus 250. That's the answer. A. Which means only 80 got scores higher than John. Yeah. I think we can stop there. Using the same principle, you can do using the standard errors. That's the sampling errors. You compute the standard deviation of those sampling errors. It's called a standard error. Then you can make these estimations. You can be able to say how far away is your sample mean from the population mean. Otherwise, wish you the best. See the rose design. Yes, zikanako matika na kandi class na usokolo koma basime. Zina zote zake za sokolo mkazabo zapanga masters PhD. Hadi tizaongezela.